Okay. So a curve of best fit. The real name for that is quadratic regression. You already know about linear regression. I think I spelled that wrong. All right, so let's remind ourselves how linear regression works. We call that line of best fit. So if you have a bunch of x values, you have a bunch of y values, go ahead and plot these things as best you can. They don't have to be perfect. I'm trying to think what the little scale is here. So go ahead and put them in. Just to kind of remind ourselves what we did with this. All right, one over here. I may be missing them a little bit. I'm doing my best here. Everybody's putting these in? Yeah. Right? Get this little thing here. And so remember what we kind of did with this? I think I gave you spaghetti, didn't I? Yeah. And so you put a line here, and then we used 2 points on a line. You can figure out, find the slope, use y minus y1 equals n times x minus x1, make a guess. But then we want the line of best fit. And that was a big statistical process that fortunately our calculator can do for us. So let me see. How do we do that again? Oh, there's so many words here. So let's just remind ourselves how that works. So you get your calculator, do this with me. Remember you press stat, you press edit. Now what goes in L1? Your x values, what goes in, yeah, okay, so let's quickly, you'll be faster than me because I was sitting there struggling with this little funny thing here, so put them in, you're putting them in, you'll be there before me. Okay, so you guys are way ahead of me. So, all right, so I'm like you putting these in here. Now let's again, just for the record here, right? So we say stat, we say calc. Now which number? 5. Linear regression, number 4. Now we could hit enter. There was another thing you could do, which was press bars. Go over 1 to y bars till it says function. Press enter, enter. Now, it might be different on your calculator. I think there's a little place, but you do the same steps so the y1 shows up. I forget what the words are.
One more steps?
Yeah, just press number 4 for me. Some of them, there's a little place, yeah, that thing where it says store, rect equal, that's where that y1 would go. You press enter, and then it says y equals ax plus b. So a is your slope, right? That's like an m. And so to the nearest 100, y equals 0.19x plus, well, actually minus 7.96. Who remembers this?
How did that show up? I just forget how to get the y.
Oh, my word.
The y? Grieser, how did that work?
It didn't work?
It didn't work. It said error. What are you doing?
Did you check your input? Make sure all the numbers are in correctly?
The stats I lost.
No, that's not going to cut that. So we take this is y equals 0.19x, and I'm rounding to the nearest 100 because it didn't tell me how to round minus 7.96. That's the line of best fit. Line of best fit. So by putting this in the calculator, I can do some interpolation. Let's see if I have that on here. Yeah, so what if I wanted to know y values for values that aren't on here, right? So I know like what it is for this, so I can make good guesses. So how do I know an x is 59? Now when I did that bit with the y1, and I'll remember what you did, you do bars, y bars, press enter. That's where y1 comes from. All right, but I'm not really doing it. If you look in the table now, because what that does is it puts that equation in there, that big long array equation, and you can look at the table. And now if it says, what's the value when x is 59? It's like, well, I can scroll there, or look above here where it says table set. Second, table set. And then I'm going to start where I want to be. Start at 59. And then when I go back into my table, second table, 59, I should get approximately, and here, let's see what that says, 3.12. At 64, I think it's going to be about 4.06. At 67, I think it's going to be 4.62. All this is doing, you want to do it by hand, is plug 59 in here, figure it out. Or plug 64 in here, figure it out. I'm using the table to make that calculation for me. We did do this, right?
Yeah.
Coming back at all?
Yes.
Not at all. That's a problem.
How do you lie about this from my
Okay, I will show you one more time how to do that. Okay? How do you get the formula in the y1 equal? Is everybody watching? Stat, calc. Everybody's watching? Press number 4. At this point, you go to the vars button. Press it. Go over one to y vars. Press enter, there's y1. When you press enter now, this equation is put under y1 equals. Yeah? And that is our review. Now, I want to kind of move on beyond the review because there's a bit of regression analysis you have to do now. The line of best fit makes predictions, right? If the data is linear. What if the data isn't linear? What if it looks like something else? So what if it looks like a quadratic? Okay? Now, if you want to see what a quadratic fit is, watch. Everybody's watching because it doesn't look like it. You press stat, you press calc. How would I do a quadratic regression?
5.
Look at number 5. And then you press, I'm just press enter for now. Y equals ax squared plus bx plus c. So negative 0.05 x squared plus 6.68x minus 210.86. That is the best quadratic fit for the data. So if I were looking at this, it's basically saying I'm trying to get some kind of quadratic shape in here. Trying to figure out what that is. And that's what this is. Notice how it's negative? So it's trying to get a concave down figure, which makes sense in a way. So it's giving you that equation now because some data is quadratic more than it's linear. So here's a quadratic regression example. So let's see, we have this on your thing. Yeah, it's on the back. It's on the back there, example 1. So it shows monthly sales for a hair salon. Month 0 represents March. So what's month 1? April, right? Month 2 is May. Sometimes it's helpful to kind of write the words here so you can kind of think about what you're doing. Find the best fitting quadratic model. So what am I going to do? Stat, edit, clear out what's in here. I'm going to clear them out, go over, highlight the L1, press the clear button, hit enter. What goes in here? 0, 1, 2, 3, 4, 5. Write your X data. So put that in. 3, 4, 5. Whoops, that didn't follow. Okay. And in my Y data, I'm putting this stuff. 5.6 to 5.8. Should be on your paper, so you can put them up. You will get there before me. 6.9, 7.9, and I am just taking 1 second just to check that your data is input correctly. If it's not, you garbage in, garbage out. Okay. So now I want to see what that model is. So I'm going to hit stat, calc, quadratic model. Press number 5. Press enter. So I'm going to round to the nearest hundredth when it doesn't say. So 0.12x squared. So y equals 0.12x squared plus 0.07x. And then plus 0.6, 5.6, right? Any questions where this came from? There should be a 6 like this. What's happening here?
No, you're right.
I was right. Yeah, yes. Yes. Yes, you do. Okay, now when they, oh, sorry, yes, question? What do you mean? Okay, look up here at the quadrant. See over here where it says y equals ax squared plus bx plus c? So here's the a value that you're going to plug in here. Here's the b value you're going to plug in here. And here's the c value you're going to plug in here. Remember that quadratics are the ax squared plus bx plus. Does that answer the question? Okay, good. Now, how are you going to predict the total sales for September? What do you need to do here? Well, what do I need? X equals, Ryan? September is what input? 6, right? One way to do this is to plug a 6 in here and kind of do that manually, right? You could do that. You should still get a good approximation. Or get it in the calculator. So let's review how that's done, because it's just like what we did with the linear. Watch again, everybody's eyes up. So you press that, calc. I'm doing a quadratic regression. Now I press bars, move over 1 to y bars, press enter, press enter. When I press enter again, this big mess is now in my y equal, which means my table now has values. Stat, and then the graph plot, and I'm in the table. September should be 6. Now you can scroll, scroll, scroll. You can also go to table set and get there a little faster. I'm just going to type in a 6 and then go back here. 10.45. This is really exactly the same as what we did with linear, except instead of saying lin reg, I'm saying quad reg. Who is with me? Who remembers this, doing this for linear regression? It's the same thing, but now it's quadratic. These are the calculator steps. Now, here's a question. How do you know if theta is linear or quadratic? How do you know? Yeah? Well, how do I know? How do I know? Yes. Well, if I want quadratic, I know to write this. But how do I know it better fits like a quadratic line versus a line? And I'll answer that question for you. You may not remember this thing called R. Okay, so I don't know if you remember this. Now, diagnostic on. Some of the calculators, you can get to it from the mode button. This calculator, you can't. Some of them will have something about diagnostics on there. He's got like a more advanced one. If you press your mode button, there should be something that says something about diagnostic on or somewhere in there.
Yeah, it's on the TIE.
It is. Now, you are not using your calculator when you take the SOL exam. You may get one like this. So what you do is you have to go to the directory, and I probably will troubleshoot it. Where's the directory? Second zero? Okay, so you press the second button and 0 to get to the catalog. And now I want diagnostic on. Now you can scroll, scroll, scroll. See this A button? It means the alpha key is on. So look for this color where a D is. And I see mine right here. I think yours is going to be in the same place where it says X minus 1. That gets me to the D's. So it's just a little bit faster to scroll. I'm looking for diagnostic on. Press enter. Then press enter again. If you don't press enter again, it's not doing it. Need that word done. Now, anytime the calculator clears out, that's gone. So let's say in the beginning of a test, you should put that right in there. You should be fine until the calculator is cleared out again. But what happens when you do that is the next time that I do a stat, a calc, a quad reg, I now have something called R squared. And R squared is the coefficient of determination. And its value is 0.9995 rounded. But if this value is 1, it is a perfect fit. Is this number close to 1?
Yes.
That's a pretty good fit. So it's a pretty good quadratic fit. Now remember what we did with linear. Now run linreg with this data. So I'm going to do a stat, a calc, and a number 4 this time. I'm running linear regression, and I'm only doing that because I want to see its values. Now we've talked about R, correlation coefficient. It also needs to be near 1. R squared is a coefficient of determination for linear stuff. But look at its value. 0.9, which is bigger? 0.9995 or either of these things? Which is the better fit then? Quadratic. So you can tell the better fit by looking at this. The uppercase R squared is for the quadratics, and you can use really either of these. I guess we should use a little R squared, and then whichever one is closer to 1 is the better fit. Okay? We heard that.
Yes.
Any questions on that? We've done these calculator steps before. We've done them. We have. Okay, so here is another example. We did an experiment by rolling a marble down different slanted boards. So basically this is time. It's actually almost always our x-axis. And this is how far it went in centimeters. So take a moment and plot those points. So my data is now, I did a stat, I did an edit, and I input into L1 all these values, and I input into L2 all these values. My plot is some more or less something like that. What is the quadratic curve of best fit? Stat, calc, number 5. Now watch again how we get that into the table. You press the vars, move to the right one, y vars, press enter, press enter. Now if you have a different calculator, what is it, store rec EQ or something? That's where that y1, all the var steps go. If you have a different calculator. You press enter. Now this is the equation that it's getting. So y equals 0.51x squared minus 0.08x plus 0.04. So let's see if we can get that written in here. So let me see. There's a lot of stuff to write. So the equation, what is the quadratic curve of best fit, is equals 0.51x squared. And I'm reading, I rounded to the nearest hundredth on my calculator. There we go. Okay. So it's doing its best quadratic fit. So first of all, is this a good fit, do you think? Let's look again at what that coefficient of determination was. Bring that back up. 0.9999. Is this a good fit?
Yes.
Pretty good, right? It's nearly 1. That's pretty good. So based on this, how long would it take for the marble to roll 15 centimeters? Whoa, careful now. Is that an X or a Y? 15 centimeters. An X is time, Y is distance. Did they give me a time?
No.
They gave me a distance. So when I look in the table, I'm looking on the right, on the Y values. So here's my table, so second table. I'm looking on this side. So it's some number between 5 and 6 is where I'm going to get there. If you can't see where it is, once again, look over here by table set. I'm pressing second and that window. See this delta table? I'm going to change it to be 0.1. Now what does that do? Well, let's see. I'm going to go back in. Look at this. It's going by 0.1s. So I have more preciseness here. I'm scrolling and I'm looking at the right. Looking at the right, looking at the right. When is it about 15? Well,
5.6.
it's either 5.5 or 5.6.
5.5.
Yeah, maybe it's 5.5. So I think the answer to this question here is, how long will it take? About 5.5 seconds. If you said 5.6, I probably would say that's okay. Now it says, approximately how far will the marble fall in 3 seconds? Are they giving you an X or a Y?
A Y.
X, right? The time. So let's go back into the calculator. And now I want 3 seconds. I could change my delta back, being lazy. But I want to go where X is 3. 4.37. And what are my units? Centimeters. That's how far we think we could go. Now, when we looked at R squared, because this question says, how do you know this is quadratic and not linear? Well, let's see, R squared, remember what that was? Where? I don't know if I can still see it. Let me go back out. R squared, 0.9999, right? Oh, let's write that down. It was like a whole bunch of 9s. Let's look at linear now. I'm going to run the linear, but I'm not going to change my Y bars. I'm just looking at it as a test. Press stat, press calc, number 4, and just hit enter, because I'm interested only in these values. So the R squared, little r squared, 0.92. Go to catalog and diagnostics. Didn't get there. Okay, so 0.92, which is closer to 1? This one. This one is for quadratic. The quadratic fit is better because the coefficient of determination is closer to 1 for a quadratic fit than it is for a linear fit. Yes?
So you should always try and get it as close to 1.
Yes. Always, the closer it is to 1, the better the fit. If it's exactly 1, boy, that's perfect. Alrighty.
More than one.
Huh? It won't be more than 1. Won't be more than 1. What's this? Nothing. Okay. We made it. Are there questions? Yeah, I mean, that's it. That's the whole thing. So are there questions on this? We seem to have forgotten a lot of that linear regression. So this is a review of that, as well as the new thing. Hang on for 1 second. I just want to sit down, please. Yeah, just sit down for a second. Somebody asked about questions. I just want to point it out. You will sometimes see questions where the number, I don't know, I'm making junk up here. And they say, what's the best equation for this data? They'll have A, B, C, and Y equals, right? They'll have a bunch of them. How do you do those?
I plug it in.
How do you do it? Slash and drag? You know what I would do? I would go to stat edit. In the L1, I put these, this.
Oh, yeah.
In L2, I put this. Press lin reg, blah, blah. It's going to tell me what the exact equation is. So this thing works anytime you have x's and y's, you have this table, if you want the equation. So think creatively, and only because 50 plus questions, your brains are going to explode. So if there is an easy way to get through something, do it. Nothing wrong with
What
that.
about the ones that have like 1, 2, 3, and then 4, 5, and then a blank?
Okay, what if this one was 4 and a blank? Why don't you just put these numbers in, get the equation, and plug in 4? Right?
Or a table.
Or a table. So, you know what I'm saying? So use this stuff. You know more now. Be smart. Use that stuff.